when you come in on Tuesday.
Sure for what's important.
Is there actually?
No,
I think
All right, guys. So, what are examples of attractive forces? You, Daniel. Appreciate it.
I have one.
Thank you. Gravity. Cheetah.
Me.
You?
Answered the question.
Magnetic.
Oh.
Okay. Sure.
Yeah. Anyone else?
Wait, where?
What's this?
What?
Name an attractive force.
Gravity.
We've already said that. Name another one.
Attractive forces?
If you took
Electrostatic forces.
yeah, if you took chemistry, you should know.
Like Coulomb's law, like stuff like that, like cool stuff. What's that
Strong
called?
nuclear.
Van der
weak-
Waals force. Yeah.
Maybe I don't know.
Electrostatic force.
Well, Van der Waals is actually it's an English.
Yeah.
Whatever.
Okay. That was
Alright.
good.
So we're here today to talk about a different force of attraction.
You want to do
That is laws of attraction. Ready? Good. All right. So first we have Dr. Rahul Ramnath. He's professor of women's studies. He has a PhD in smooth talking from Columbia University, and he won the Nobel Bro Prize in 2004. I think he has collected some of his best works of people singing in finesse, and I appreciate it.
Thank you. Appreciate it. Okay, and now we have Professor Zheng, sorry, in women's studies. He has a PhD in DM sliding from Princeton University and is a tenured professor there. His win-loss streak with girls is 0 to 11. And as you can see there, he's finessing every single girl, from random high schoolers to Miss Howard County, of course.
I did my research. And then last but not least, we have the real Mr. Watson here. He's actually our guest today. He's an international guest speaker. We're pretty sure he went to school. We're not sure, but your parents pay tax dollars, so you get what you get. He's fluent in different tongues. He's good with French kissing, Spider-Man kissing, and Espanol.
Wait, don't forget butterfly kissing.
And butterfly kissing.
Yeah.
Alright, so let's go physical.
We're going to start with the mechanics of love.
Alright, so if you guys remember, we started this year with Newton's 3 laws. Newton's first law is a relationship in motion tends to stay in motion, while one at rest tends to stay at rest, unless acted upon by an outside force. This is what we call romantic inertia. So certain factors, certain outside forces can range from infidelity to stalking her cousin and then inviting her to a tea party without letting her know that he's there. But okay. All right, second law. Anyone know Newton's second law?
We use it every day. You get 1 point on an FRQ for this. You all should know it.
F equals ma. There we go.
what time?
So Newton's second law of love is the force of love is equal to the romantic inertia times how fast the relationship is moving. Now there's a certain quantity of its units are given by bases, as in first. Yeah, I'll stop there. But you get the picture.
Oh, excellent, Daniel.
Some people get home runs.
And then we have Newton's third law, which is that every action has an equal reaction. So with this law, we can start drawing free body diagrams, and we can assign positive and negative signs to indicate direction. Hopefully, romantic is positive, but negative signs can indicate creepy or
Pervert.
Ooh. Let's have a moment of silence.
Moment of silence for Daniel.
Alright, moving on. After we learned attractive forces, we learned about resistive forces, right? So one resistive force is socioeconomic status. So if you guys seen Titanic or Notebook, you know exactly what I'm talking about. If you've cried during Titanic and Notebook, you know what I'm talking about. Okay? Next we have right person at the wrong time. And then we have distance.
An example of this would be, let's say a girl's from Colorado.
leave it at that. I'll leave it at that.
That would be an example of a long distance relationship that didn't work out.
Another resistant force is if you guys are both members of rivaling families. Now, last but not least, choose your cousin. I'm serious though. Don't. Enough said.
This is very serious, guys.
Alright, so more mechanics. After we learned about Newton's laws, we learned about conservation of energy, right? And energy is in two forms. We have potential energy and we have kinetic energy. So potential energy, we have the equation U equals mgh. Basically, that's saying the potential of a relationship with the partner depends on his height.
It's height.
Anyways, the kinetic energy, however, varies squarely with how fast a relationship is moving. And from that, we can determine how much work someone is putting into a relationship based on how much the change in kinetic energy they're doing. And then, last but not least, we touched upon momentum of a relationship, which is how fast a relationship is progressing times its romantic inertia.
So now moving on to the electricity and magnetism section of this presentation. Just like magnets, with people, opposites attract and likes repel. But this is 2017, so who am I to judge you?
One moment, please.
You're not on camera.
No, she had
18 plus. Alright.
So, continuing, there are three methods of charging. The first one that everyone knows is induction, in which you take a charged object and you bring it in contact with a non-charged object, thus transferring some charge. The second is by induction. You bring a charged object close to a non-charged object, you ground that second non-charged object, you remove the charged object, you remove the ground end. The charges remain. But there is a third method of charging that follows that. And that is seduction.
Oh my
You know it's coming. I can introduce the steps.
Oh, that's an actual picture of Mr. Watson. Skeptics have said that it's Photoshop, but they're
Animation here.
Oh, he's doing it. Okay.
let me get the box.
No.
I can just
That's why.
Alright.
I'm starting to see. Alright, so this brings us to Casanova's three methods of seduction. Daniel will demonstrate, but he's going to need a partner. Any volunteers?
Jeffrey! Alright, so Casanova's
Jeffrey, go.
Casanova's first law of seduction is music and dance, right?
Jeffrey,
There is
come
no grander gesture of
Jeffrey,
love
you're going up here.
than passionately dancing and serenading your partner.
Get the camera. Mom, get the people.
Can you put the thing in Spanish?
Allow me to demonstrate. So,
Yes.
as so tracks of beat, begin circling it to attract its attention.
Now to step two. It takes passionate eye contact with the subject. It's very gaze.
see how you're 0 for 11.
Alright, last but not least, you can use your words, right? Now, this is interesting because research has shown that people actually like each other for their personalities, right? So, the key here, right, is smooth talking will get you into someone's heart in any relationship.
Or house, car, or bedroom.
PG. Alright. So, you know, the guy's first move is going to often be a pickup line, but if those don't work, you can always try a romance language. Spanish, French. They're called romance languages for a reason. Otherwise, if you're not good in multiple tongues as our guest speakers, you can tend to poetry for matters of the heart. Allow me to demonstrate.
Let's have a volunteer from the crowd.
Yes. Jeffrey again.
Let's have
Jeffrey!
Frank.
Yeah, Frank.
Alright, so we're at a non-alcoholic bar. So you walk in and you see a beautiful man or woman, I mean, whatever you're into, and you don't know how to start a conversation. Best advice is to literally just break into poetry. Allow me to demonstrate. If you're happy and you know it, clap your hands. If you're happy and you know it, clap your hands. If you're happy and you know it, then your face will surely show it. If you're happy and you know it, clap your hands.
Next slide, please. So now we go to Coulomb's law. We actually begin the E&M fun. We define Coulomb's law as the attractive force between two people, or the spark that connects us. In classical physics, we discuss this as the distance affects how the heart grows fonder. So the longer the distance away, the less fond the relationship becomes.
Sorry. In classical physics, the thought used to believe... The standing theory was that distance makes the heart grow fonder. So the further apart you are, the more connected you feel. But
Sorry, that was post-Newtonian. So now we're going to post-Newtonian physics, and we describe this as one phone call eventually becomes one FaceTime per week, and eventually becomes not hearing their name 10 years later at a high school reunion.
So we have a formula for this concept of the spark, in which Q is the attractive charge of the person, typically defined on a scale of 1 to 10. K is the universal love permittivity constant,
Measured at 2.14 times 10 to the 7th.
and D is distance.
If you guys paid attention in mechanics or physics 1, you would recognize that this would be your gravitational equation for describing force of gravity between two objects.
But your test averages suggest otherwise.
Yeah.
Sorry.
Next slide. Oh, one more slide. Sadly, no one cares about this, and you guys are all too young. We can't go into this unless you're over 18. So. And now we have the great right-hand rule. Daniel, would you like to another volunteer? Perfect.
Arthur Zheng, thank you for raising your hand. Alright, so if you guys remember from cross products or doing torque, you recognize this right-hand rule, which is the cross product gives you an orthogonal vector. But there's also another orthogonal vector where, for example, in torque, if this is your radius of rotation, this is going to be the direction in which it's rotating, right? But this also applies in attraction, in that I'm very attracted to you, so my hand is going to crawl on.
Stand still, and then something else will also happen, but that's for another class, of course.
Oh boy.
Everyone here already took out, so we're
We're good.
going to skip over.
Yeah.
Alright, so we have an FRQ for you guys.
Yeah, we're actually gonna do this.
Objective, get to this slide. That's just classical.
First 5
Okay,
periods.
it took us like 5
It took us 5 periods. This is actually a really good lesson. You have no idea.
Alright, I know. If you want to.
Okay, so. Okay.
So, it's not a warm-up, but a cool-down. Romeo are a hard 6 and Juliet hot a solid 8. Given that these star-crossed lovers are dust from Centennial and Hebron, distance 7,680 meters, calculate the spark between these two teenagers. The formula for spark being given, as earlier, as Coulomb's law. Can anyone tell me how to solve this equation?
This is very simple, guys. All you have to do is plug it in.
Let's plug everything in.
Care to demonstrate?
Let's give it up to volunteers.
Alright, so F equals to that equation. So K is 2.14 U7 times. So Q1 is 6, that's for Romeo. Then I have an 8 for Juliet. And then over distance square, distance is given as 7,680. Let's square that. And then we're going to do this on a calculator.
No, do it in your head. Easy.
Easy?
Yeah,
Easy
don't worry
peasy,
about it.
lemon squeezy.
Does anyone have
Yeah,
a
I'm on the
calculator?
Arnold problem.
Oh, do the computation.
In your head.
Yeah, pull up the calculator.
5 points for Gryffindor.
Spanish translators are gonna help you. Anyone, calculator, numbers.
Hey,
Remember
I don't know.
13.42. Okay, alright, let's go to see please. Cool.
Awesome. Okay. You did the Sparks, of course.
Nicholas Sparks,
Nicholas Sparks.
author of.
And now we set this equal to 20 newtons as the new force, and we solve for Romeo's charge of Q. Would anyone like to?
Basically, the question is, if the assumed tension between them is 20 newtons, how attractive must Romeo become in order to maintain a two-month high school relationship?
In other words, Romeo must induce more sexual tension between him and Juliet. Volunteers. Volunteers.
Take a seat.
You guys have a I worked at Miguel.
Does anyone have any idea how to do this? Shayak.
Give me a sec.
You can draw a free body diagram.
Where's Gabby?
This here is Romeo. Juliet. Can anyone tell me the forces affecting Romeo and Juliet?
Force of gravity.
Just name some
Force of
forces.
gravity?
Gravity.
More forces, more forces.
Force normal.
Normal force.
Seductive force.
Exactly.
Would someone like to come up and finish off the rest of the equation and solve it? Would someone like any volunteers? If you don't raise your hand, I'm going to choose you.
Shaq, you want to just finish this off first?
Wait, no, not Shaq. Shaq knows how to do this. We need to choose someone else.
Alright, I'll just add the last one on.
I don't know your name.
Claudia!
Yeah, Claudia. Yes, yeah.
Get up there.
The equation's there. What do you do? It's really simple. Oh, yeah. It's simple. Just plug it in. Question, yes.
I don't know this!